Today we're going to talk through the 2014 No Calculator Multiple Choice Practice Test for the Calc AB test. During the recording, I'm going to give you kind of things to look for as you read the question, talk through definitions, keywords, things like that. More than just a let's do the problem, let's be a little tutorial as we go. Okay, so let's get rolling. Question number 1. Looking for the integral of 3t squared minus 1 from 2 to x. Basic power rule. So when I do this, I have the steps. I add 1 to the exponent. So it was t squared. So now it'll be t to the third power. And I divide the old coefficient by the new exponent. So 3 divided by 3 is 1. And the derivative, or the integral of 1, is just t. So there's our antiderivative. And now I'm going to use a fundamental theorem of calculus, and I'm going to evaluate that from 2 to x. Now I know on a multiple choice test you don't have to show all your work, but I want to show work again because this is more of a tutorial as we go. Hopefully it's not too painful, and you can go a little faster if you need to, but that's kind of my goal. So this becomes, plug in the upper bound, I get x cubed minus x. Plug in the lower bound, and I'm going to subtract this next expression. Technically there's a parentheses here, which I don't really have to have, but it's technically there. Second parentheses is a 6, and my final answer is x cubed minus x minus 6, letter A. Basic power rule, antiderivative, integral, etc. Okay, so question number 2. What is the slope of a line tangent to the graph? As you read, you want to try to translate words into calculus terms, calculus notation. Slope, I'm thinking derivative. So I want to take the derivative. So I want y prime. Derivative of natural log is 1 over the expression. There is a chain rule because the inside function is more than just x. And so I have multiplied by 2. I'm evaluating that at the point when x equals 4. So this becomes 1 over 2 times 4 times 2. Final answer, 1 over 4. Letter B. Okay, keep on rolling. Question number 3. We're given a function f of x. Same procedure. We're looking for the derivative at a point. So first one is just power rule. So I have negative 2 times the coefficient, so it becomes negative 8. Decrease the exponent by 1 this time because it's derivative. Be careful. Negative 2 minus another 1 is a negative 3. Multiply the 2 times the 1/4, and I get a 1/2. Again, decrease the exponent by 1. Derivative of a constant is 0. Plug in the 2. Remember what a negative exponent means. It means 1 over the expression without the negative sign. Plug in the 2. Final answer, this is 1 over 8 times 8, which is a negative 1. And negative, or 1/2 times 2 is a positive 1. Answer is 0. Letter D. Question 4. I'm going to do u substitution, but I'm not going to do it formally. So I'm going to think of my 2x plus 1 as my u. Whoops, 1 to 2. And so the function whose derivative is, whoops, just rewrote the expression. The function whose derivative is 1 over something is natural log. So this becomes a natural log of 2x plus 1. And if I think about the derivative of this using chain rule, I'm going to have a times 2 out in front of here. But I don't have a 2 in my original expression. So I'm going to multiply both of the, or not both, but I multiply by 1/2 in order to get rid of that 2 that would have shown up using chain rule in my derivative. We're going to evaluate that from 1 to 2. Leave the 1/2 alone. Plug the 2 into my expression, I get 4 plus 1 would be 5. Minus, leave the 1/2, multiply, or plug the 1 in, I get 2 plus 1 is 3. So we get the natural log of 3. Looking at my options, it looks like letter E if I factor out a 1/2. And that's going to happen quite often, where what you write isn't exactly the way they have it written in the multiple choice, and you just have to find the answer. Do a little manipulating, a little rearranging, and it looks like question 4 is E. Question 5. Looking at a graph of F. Super important that you look at what you're looking at. Is it F? Is it F prime? Is it F double prime? So this is F. Which of the following statements are true? The limit as x approaches 2 from the left for this function. The limit as x approaches 2 from the left goes to the same value as the function. Yes. How do I know? Because of the closed circle. As I approach 2 from the left, it does go to the value of f of 2. Number 5, A, yes. Which of the following statements are true? Yes, for number 1. Number 2, as x approaches 6 from the left, as x approaches 6 from the right are the same. Yep, check. The limit as x approaches 6 is the same as the value of f of 6. There's f of 6, there's my limit. They are not the same. So it looks like questions 1 or statements 1 and 2 only. 5 is letter C. Probably the key things in here is looking at left, looking at right, and the limit is from both sides, which is our definition of a limit. Question 6, derivative of a mess. So we have a little chain rule going on here. We have a lot of chain rule going on here. So if it helps, I'm going to write this as sine of x squared cubed. So recognizing that the power, the cube, is my most outside function. And now I'm going to take the derivative using chain rule. So I have a power rule first. So I have 3, leave the inside alone, decrease the x1 by 1. Derivative of the inside function, derivative of sine is cosine. The most inside function is x squared, and the derivative of x squared is 2x. Combining some like terms, and it looks like we have letter E. Key on this one, recognize what function is the most outside, and then work your way in from the most outside to the inside. Question number 7. We have limit as x goes to infinity of x cubed over e to the 3x. To evaluate a limit, whether it's going to infinity, 0, 1, doesn't matter. I'm going to plug in the value, if possible, to my function for x and see what happens. We get infinity to the 3rd power. We get e to the 3 times infinity. Clearly it's infinity over infinity. L'Hopital's rule. L'Hopital's rule says take the derivative of the top, take the derivative of the bottom. Not quotient rule, simply the top and the bottom separately. Use in a multiple choice, I don't have to have good notation, so I'm just going to take the derivative. X cubed is just a power rule. Derivative of e to the 3x is e to the 3x. Chain rule says take the derivative of the inside function, which is my exponent, and I end up with this. Once again, I think we can quickly see it's infinity over infinity. Do power rule again. Top becomes 6x. Bottom becomes 9 e to the 3x. Plug in infinity. Again, I get infinity over infinity. Take the derivative again, and I get 6 on top, and I get 27e to the 3x on bottom. Now when I plug in infinity, I get 6 over infinity, and 6 divided by infinity is 0, and so my function is, or my limit is 0. Notice we have 0 on the bottom and something divided by, we have infinity on the bottom, and something divided by infinity is 0. Something that divides by a very, very large number is 0. Okay, question 7. Question 8, that was 7. Question 8, using the substitution given, so I'm going to replace the sine 2x with u, and so this becomes u to the 5th power. Cosine of 2x dx is my, whoops, didn't want to write that. If u is sine 2x, then du is equal to the derivative, which is cosine 2x times 2. So I have a cosine 2x times dx here, and the 2 is not there, so I need to get rid of the 2, so that goes away. So 1/2 du is that, so I'm going to stick the 1/2 out in front. Now, these upper and lower bounds are in terms of x. We have changed our derivative to be in terms of u. So I need to change my upper and lower bound to match. So here's my definition of u. U is equal to sine of 2x. So u is equal to sine of 2 times pi over 6, which would be pi over 3. And sine of pi over 3, if we remember our right triangles, it's a 30, 60, 90, right? So this is our 30, this is our 60, this is our 90. And my 1, 2, square root of 3. And so this becomes square root of 3 over 2, because 60 degrees is pi over 3. So this becomes square root of 3 over 2. Now there's lots of ways of doing it. Some of you may have that memorized, but I just wanted to show it to you on a right triangle just in case you don't have it memorized. Plugging in pi over 2, I get u equals sine of pi over 2 times 2, which becomes the sine of pi. And sine of pi, remember on the unit circle, pi is sitting over here. Sine is my y value, so the sine of pi would be 0. Looking at my options, I get letter D. There's a lot there. Hopefully we recognize all the different things. I'm going to erase my scribbles for a second so you see the original expression. And let's just talk for a second. Key in here, I think, is to recognize that this is in terms of u, and in terms of x, and I want it to be in terms of u. So when you do a u substitution, everything needs to be changed from x's to u's, including the upper and lower bound. That's probably the key in that one. Okay. Question 9. Function f has a derivative given by that function. That is my derivative function. Super important. Recognize this is my derivative function. At what values of x does f have a relative maximum? Relative maximums occur where my function goes from increasing to decreasing, where my derivative goes from positive to negative. So, my opinion, easiest way to do this is, let's put our zeros on a number line. So at x equals a -1, at x equals 0, and at x equals 3. I'm going to sketch this like a polynomial. You could plug in values for x that are to the right and left of each of these zeros and come up with a sign, positive or negative, that would match, okay, or represent that region, not really match, represent that region. I'm going to do it by graphing as a polynomial. So if I put in a number that's bigger than 3, as x goes to infinity, this function has a positive leading coefficient, and so that function is going to be above the x-axis, and it's going to come down from here. We know from pre-calculus that if a factor that gives me the 0 is squared, or an even power, it will bounce off of that. So let me tweak that a little bit too much of an angle. Let's come in, it's going to bounce off of that. It's going to pass through and pop up. My graph is positive, positive, negative, positive. If I picture this as an XY axis sitting here, that's what my graph would look like. Yes, you can always plug in points to double check that. But if you understand how to graph, really saves me a lot of time. Okay, what do we want? Relative maximum. We want our graph to go from a positive derivative to a negative derivative. It goes from a positive to negative at -1. Not at 1, that's a minimum, and not at 3, that's a plateau point. My function is increasing, and then it's increasing again. This is my derivative graph, remember, right? This is my derivative graph. This is not the graph of what I'm looking at. I want to know what's the maximum in f. This is f prime. Okay, so this is a plateau point here at 3. So what's my answer? Looks like 1 only, letter A. First derivative test. Okay, f is a function above. Again, it's f. For what values of b is f continuous? In a piecewise function, as long as each function is continuous by itself, the only problem happens when you switch definitions. Okay, so in this case, though, it's not continuous. The top function's not continuous at x equals -2. However, we got some things we got to look at. So I'm going to rewrite that. I'm going to factor the top into x minus 2, x minus 5. And this is good for x equals not equal to 2, and this is for x equals to 2. Remember, these go away. That's a 5. And so when I plug into 2 into that, I get -3, right? When I plug in 2, I get -3 over b. In order for this to be continuous, so remember what we have right here. What does that do? That gives me a hole. In order for this to be continuous, whatever my definition of f is at x equals 2, it must fill in that hole. So then this -3 over b from the top definition has to equal b from the bottom definition, or from the definition at x equals 2. Well, let's solve that. So I cross multiply, so b squared needs to equal a -3, and we know that b squared will never be a -3, so my answer is E. There is no such point. However, had this been a positive, then we could have found a value for b that would have plugged that hole that we just plucked out of it. Okay? Removable discontinuity is what the technical phrase is for that type of discontinuity. Question 11. The graph of f prime, graph of f prime, the derivative of f is a piecewise function shown above. F of 0 equals 1, key part. What is the maximum of f? Given f prime, I want to know something about f. A little tutorial. If I integrate from 0 to 3 of f prime of x dx, what does that tell me? This tells me how much change in f from time equals 0 to time equals 3, or from x equals 0 to x equals 3. If I knew where I started, which I do, and I add the amount of change, I'll know where I end. So this will give me the value of f of 3. On a free response question, being able to do that right there, super, super important. For multiple choice, not so much. You need to understand the concept, but your notation doesn't have to be written down. But it's a good skill to be able to do. Okay, so f of 3, how do I find the value at 3? I integrate from 0 to 3. Why do I care about the value at 3? Why did I pick 3? Notice my sign of my derivative changes. So in this region from 0 to 3, my function's increasing, and then it's starting to decrease, and then it goes back to increasing. I want the maximum value. Okay, so this area underneath this curve, 3 times 2, so my base is 3, my height is 2, 6, 1/2 base times height gives me 3. Now, this amount of change down here is greater than this amount of change, so I know this is my maximum and not 6. The amount of change in the negative direction is more than the positive direction. I won't make up for this by the time I get to 6, so my biggest value is at 3. So this integral we said was 3, and I start at 1, so my answer is 4. F of 3, excuse me, f of 3 is the largest value, which is 4. Okay, question 12. Function f of x equals 9 raised to the x power. 4 subintervals, equal length, do a right Riemann sum. B minus A over number of subintervals. tells me my delta x. So b minus a is 2 over 4. My delta x is a half. Okay, for sake of space, we know that. I'm going to get rid of it. And you could have saw that. I just wanted to make sure you understood where I'm getting my delta x. So area of a triangle, or sorry, area of a rectangle is base times height. My base was going to be evaluated. So f of 1/2, f of right Riemann sum. Starting at 0, I go to the right-hand side, 1/2. At 1, at 3/2, and at 2. Those are my 4 points I'm looking at. So I have 9 raised to the 1/2, which equals 3. I have 9 raised to the first power, which is 9. I have 9 raised to the 3/2 power. Bottom number is the root, top number is the exponent. So this is a square root of 9 cubed, which is 27. And then 9 squared, which is 81. Should see the pattern as being multiplied by 3. Okay, so my right Riemann sum is, since my subintervals have the same base, it's going to be 1/2 delta x, right? We did that before, times 3 plus 9 plus 27 plus 81. So 1/2 of 3 plus 9 is 12, plus 27 is 39. 39 plus 80 is 120. 120 times a half is letter C. As long as your delta x is consistent, you can do just adding all up and then multiply by 1/2 at the end. Okay. 13. Take the derivative, good old quotient rule. Derivative of the top times the bottom minus the top times the derivative of the bottom, all over the bottom squared, written correctly, all over the bottom squared. Now I know there's a lot of people who do high d low, low d high over low low. I just like derivative of the top times the bottom minus top times derivative of the bottom, all over the bottom squared. I like saying the rules in words that make sense to the problem. So like product rule, derivative of the first times the second, etc. I use it in terms of their position and not using U's and F's and G's, and it just becomes confusing of which one was first and so on. That's just how I do it. Okay, so there's my derivative without being simplified. I don't see that anywhere, so that means they're requiring me to simplify this thing. Distribute the negative sign and the 2x. So negative 2x times x is a negative 2x squared. A negative 2x times 1 is a negative 2x. On bottom, we have just the bottom. So on top, I have a negative x squared minus 2x plus 1 all over the bottom squared. Looks to me like that is also letter C. And again, notice my notation, I'm getting lazy because it's multiple choice and I don't have to write it all, but technically this has x squared plus 1 squared underneath it. Okay, basic chain rule, or sorry, quotient rule. Number 14, velocity of a particle moving along the x-axis is given by that equation. So velocity is given. The particle is at x equals 4 when time equals 0. So I know that x of 0, okay, translating that into function notation, x of 0 is equal to 4. What is the position of the particle at time equal pi over 2? We just did this problem. Same exact concept as a couple problems ago. I want to integrate from what I know to where I want to go. I know where the particle is at time equals 0. I want to know where the particle is going to be at time equal pi over 2. If I start at 4 and I add the amount of change from time equals 0 to time equals pi over 2 for my velocity function, then I'll get my answer. The amount I start with plus the amount of change will give me my answer. So again, I'm using a chain rule, use substitution just in my head. Derivative of what function is sine? Derivative of cosine is negative sine, so I want a negative cosine. If I were to take the derivative of this function the way it's written, I would have a 2 out in front, and I don't, so I'm going to throw a 1/2 in front of that thing with my negative sign out there. And I'm going to have this 4 still out there, but I'm integrating that from 0 to pi over 2. Okay, check our trig abilities. Plug in pi over 2. 2 times pi over 2 is pi. Plug in 0. Got to be careful here. I'm going to do this. I'm going to do this. Kind of save potential problems. Okay, hopefully you can see why. So negative 1/2 stays negative 1/2. Cosine of pi is a negative 1. Cosine of 0 is a positive 1. This becomes a negative 1/2 times a negative 2, which is equal to a positive 1. Now, that was just the integral, and I have this 4 plus 1 still sitting there, so my answer is letter D, 5. Okay. (15) Y is equal to this function they're naming g of x. It's differentiable and increasing. What does that mean? That means that g prime is greater than 0 for all real numbers. So on what intervals is y equals g of not x this time, but x cubed minus 6x squared? We have a chain rule. I want to know where it's increasing. I want to know when is y prime greater than 0. Y is defined in terms of g. I know something about g, but I want to know something about y. So I want to know when is y prime going to be positive. So let's take the derivative of, I'm going to slide over here. Let's take the derivative of g. Chain rule. Derivative of the outside function. Leave the inside alone. Times it by the derivative of the inside function. Okay? So, g prime of x cubed minus 6x squared. This is always greater than 0 for all real numbers. This is always positive. So let's look at this function over here. I'm going to factor that. Do the same thing I did before. I want to know where this is positive and negative, so my first step is to know where it's 0. This is a parabola, so my parabola is going to come through here like this. It's right side up because this is positive. Well, this is positive. So my function 3x squared minus 12x is positive here. It's negative here. It's positive here. On what intervals is my function increasing? Well, if this g prime is always positive, then this function right here needs to be positive in order for the derivative to be positive, the whole entire derivative. So it's positive from 4 to infinity and from negative infinity to 0. Letter A. Positive here, positive here. Okay. 16. This is a good one. Let's do a quick graph of this thing. In order to evaluate this limit, we need to kind of know what this thing looks like. Or we could do it algebraically, but I'm going to do it graphically first. Only difference between the denominator and the numerator, the top and the bottom, or bottom and the top the way I said it, is the top has this absolute value around it. So what I want to know is, or what I'm concerned with, what I care about, what's interesting, is at x equals 3. At x equals 3, the function is 0. Kind of. It's 0 divided by 0, which is indeterminate, but we'll go there another time. So what happens to the left and to the right? So what if I plug in a 2? Let's plug in something to the left of 3. And I end up with 2 minus 3, absolute value, over 2 minus 3. Well, the top's a negative 1 absolute value, which is a positive 1. The bottom's just a negative 1. What if I plug in 0? Now I got 0 minus 3 over 0 minus 3, but the top's an absolute value, and so it becomes a positive 3, and the bottom is a negative 3, which again is a negative 1. So no matter what I plug in, the top will always be positive and the bottom will be negative when it's less than 3. A positive divided by negative is a negative 1, and there's no value at 3. I missed, but you got the idea. At 3 and greater than 3, I have a number on top that's the same as the number on bottom because they're both positive, and I get a positive 1. So at x equals 3, this limit switches definitions, and they want to know the left-hand side. The left-hand side is at a negative 1. Letter 16, or number 16 is letter B. Okay. Question 17. F of x equals that function. What is f prime of x? F prime of x. So we just have a basic e. Derivative of e to the a to the negative x is e to the negative ax times the derivative of the inside function, which is a negative a. Inside function being my exponent. Continuing on, I get negative a squared e to the negative ax. Negative a squared e to negative x. 17 looks like e. So far we have seen e and exponentials a lot on this test. Okay, student attempted to solve the differential equation, which you're going to have to do several times. First step, dy dx equals xy. I need to separate my variables. On your free response question, you get very few, as in no, points if you don't separate your variables. First step, you have to separate variables. So I'm going to integrate both sides. And step 1 looks good. Recognize that 1 over y dy is the same thing as dy over y. Okay, integrate this thing. The derivative of a natural log is 1 over y, so this becomes ln of y. The derivative of x squared is 1/2 x squared plus c. Step 2 looks good. Step 3, I'm going to solve for y. I have to get rid of the natural log. To do that, I'm going to switch forms. Natural log has an e sitting down here. And so it's going to be e to this power equals y. Hopefully that's no problem. So y equals e raised to the 1/2 x squared plus c. Step 3 is close. Not the same. Their plus c is written down here, not up in the exponent. So the answer is step 3 is where the mistake was made. Letter B. Question 19. For what values of x does the graph of y equals 3x cubed, 3x to the 5th plus 10x to the 4th have a point of inflection? Good tutorial moment. Point of inflection, where my second derivative is 0 or undefined, and big capital bold letter and, my function switches sign, or the derivative, second derivative, switches signs at that point. Function's second derivative is 0 and the second derivative switches signs. Let's go. Y double prime is what I'm looking for. So y prime equals 15x to the 4th plus 40x to the 3rd. Y double prime equals 60x to the 3rd plus 120x squared. Set that thing equal to 0. I'm going to factor out a 60. I'm going to factor out an x squared. What's left? I see an x in the first term. I see a 2 in the second term. Number line. Sketch a graph. We've done this several times now. -2 and 0 are my values for x that make the function 0. it's going to start up here on the top. Why? Because when x goes to positive infinity, my leading coefficient is positive, so it's going to go to positive infinity. So it's going to come from here. The factor that gives me the 0, if it's squared, it'll bounce off. The factor 0 has a multiplicity of 2. It's going to bounce off of that and pass through the negative 2. 0 is not a point of inflection. Yes, it is a critical value. It is not a point of inflection. Answer, letter B. Only negative 2. Number 20. First, to evaluate a limit, I plug in the value of the function. Now, we could recognize this as a definition of a derivative, but I'm going to do it using L'Hopital's first. Okay? So I plug in 2, I get ln of 5 minus ln of 5 over 2 minus 2, which equals 0 over 0. And so I'm using L'Hopital's. Indeterminate form, L'Hopital's. So I'm going to have the limit as x approaches 2. Derivative of the top. So I get 1 over x plus 3 minus 1 over 5. Nope. That's what they wanted me to do. They almost got me. Derivative of constant is 0, right? So the derivative of natural log of 5 is just 0. So that's 1 over x plus 3. Derivative of the bottom is a 1. Don't need this minus anymore. And so I plug in my 2 and I get 1 over 5 divided by 1, which is 1 over 5. Be careful on that guy right there. Don't do what I almost did. It is a constant. It is not a variable. Okay, using L'Hopital's, that one comes out super nice and easy. I'm going to leave it at that because that is definitely the fastest way. I know we're not concerned with speed, but yet on the multiple choice, on all of this, it's timed. Speed and efficiency is important. L'Hopital is easy, and we're good to go. Question 21. Functions w, x, and y are all differentiable with respect to time and are related to that equation. If x is decreasing at a constant rate, change that into calc notations. X is decreasing at a constant rate of 1 unit per minute. Think about it for a second. dx dt, the rate of change of x with respect to time, is decreasing at 1 unit per minute. Okay. The rate of y, dy dt, is increasing at a rate of 4 units per minute. Find the rate of change. Find dw dt when x is 6 and y is 20. Okay, so looking at my equation, w squared, or w equals x squared y. I see a product rule. So w prime, which I don't really want to write w prime because that's not good notation, so I'll write dw dt. Derivative of the first. Don't forget chain rule. Derivative of x squared is 2x. Derivative of x with respect to time has a dx dt in there. Derivative of the first times the second plus the first times the derivative of the second. And the derivative of y with respect to time is just 1 dy dt. Okay, plug in everything we know. When x equals 6, so there's 12. dx dt is a negative 1. And y is 20. X squared is 36, and dy dt is 4. Doing a little calculation, we get negative 240. Sorry, I got to jump down here, then erase. Negative 240. 36 times 4, what is that, 144? Doing a little subtraction, looks like letter C, negative 96. Question 22. F is a function defined by that. On which of the following intervals is the graph both decreasing? So I want f prime to be less than 0 and concave up. I want f double prime to be greater than 0. F less than 0, f prime less than 0, f double prime greater than 0. Start taking some derivatives. f prime, 6x squared minus 6x minus 12. I would always just do what I'm doing right here. Just go back, double check that I said it right, double check that you did it right. Okay, I'm going to leave myself a space because I'm going to solve that thing. F double prime is going to be 12x minus 6. Okay, set this thing equal to 0 and solve. I'm going to factor out a 6, and I get x squared minus x minus 2. Do a little factor. I get x minus 2, x plus 1. Jump down here on number line just to help me organize my information. This is going to be 0 when x equals 1/2, and then I have a 2 out here. So f prime, f prime, remember this is my parabola thing cruising through here, right? So it's positive over here, it's positive over here, and it's negative here. Plug in values for x into your function. Make sure that your parabola graph matches up, but the parabola graph works beautifully. Okay, to the right of pi over 2, to the right of 1/2, I have no idea where I got pi over 2. To the right of 1/2 is positive, to the left of 1/2 is negative. We want decreasing, so we want f prime to be less than 0, f prime to be less than 0, so in the middle here, and concave up. Less than 0 for the first derivative, greater than 0 for the second derivative. Looks to me like letter D is the winner. Number lines are great for organizing your data. Just make sure you label so you know what's happening. You may want to do that also to help you see increasing, decreasing quickly, but whatever works for you to understand what your number line is telling you. When we get to the free response video for the same test, we'll talk more about not just what it tells you, but what you need to tell somebody else about what the number line tells you, but that's for a different video. Question 23. The function f is defined above. Function f, it's a piecewise function, and I'm looking for the derivative. So let's take the derivative. Derivative of the top definition is 3 when x is less than -1, and it's a negative 2x when x is greater than or equal to a -1. My derivative will exist as long as the slopes are the same when we switch definitions. So at -1, what happens? Well, the top's always 3. The bottom becomes a positive 2 when I plug in a when I plug in a -1 for x. 3 does not equal 2. My derivative does not exist. We have like a cusp and a corner. We have a slope that goes like this, then it goes a little bit flatter. That is not differentiable. Okay. Question 24. Horizontal asymptotes. A couple ways of doing this. We can definition horizontal asymptote. What's the limit as x goes to infinity? Horizontal asymptote. What's the limit as x goes to infinity? So if I think about this, on top, when I multiply that thing out, when I distribute all that out, all I care about, remember back from pre-calculus, your rational function rules, if the function's going to infinity, we have 3 different options. The limit doesn't exist, or it goes to infinity. It goes to 0, or it goes to some number, and that's based on the degree. If the degree of the top is bigger than the bottom, it goes to infinity. If the degree of the bottom and the top are the same, it's the ratio of the leading coefficients. And if the degree of the bottom is bigger, it goes to 0. Leading coefficient. So this term times this term. So negative 12x squared is on top. And I don't really care about all the rest. On bottom, I get 4x squared. And I don't care about everything else. Because remember, the bottom is 2x plus 1 times another 2x plus 1. And I really don't care what happens out here. The degree of the top and the bottom are the same. It's the ratio of leading coefficients. My limit as x goes to infinity, or my horizontal asymptote, is y equals -3. Okay. 25. Y equals x squared minus 2x. U is equal to 2x plus 1. Then dy du equals what? Couple options on how we can do this. I'm just going to take the derivative of y the way it's written with respect to u. So dy du equals 2 times x times dx du, because I'm taking the derivative, I'm doing this. I'm taking the derivative of this with respect to u. Why? Because that's what it tells me to do. Okay? So then this becomes minus 2 dx du. I'm looking for dy du, and I have this mess in terms of dx du's. I don't see any dx du's in my answers. So what is dx du? Well, let's go over here to u. I have a definition of u equals 2x plus 1. Let's take the derivative of that thing with respect to u. So du is just 1 because it's with respect to u. It's like taking the derivative of x with respect to x. The derivative of 2x is 2 dx du, and the derivative of a constant with respect to any variable is just 0. So dx du looks like a half. So wherever I see a dx du, I'm going to stick a 1/2. And I'm going to solve. So 2x times a half is just x. 1/2 times 2 is just 1. And it looks to me like it is letter D. That's probably the easiest. We could have solved this thing for x and substituted in. I think what we did pretty good. I like it. Question 26. Derivative of an integral. Fundamental theorem of calc part 2. Take the upper bound as long as it's just your variable x, and the lower bound is a constant. Take the upper bound, plug it into the function, multiply by the derivative of the upper bound. This one you should have memorized. Whoops, not a u. You should have this one memorized, but if not, I'll just show it to you real quick. Square root of x is x to the 1/2 power. Using power rule, I get 1/2 x to the negative 1/2, which becomes 1 over 2 square root of x. In my opinion, that is one I would have memorized. Okay, times 1 over 2 square root of x. Looking for that in my expression, don't totally see it, but I do see that this cancels, right? So I have 1 over 1 plus x times 2 square root of x. Now I see it. Letter A. Square root cancels a square, vice versa. Square cancels a square root. Okay. 27. Particle moves along the x-axis so that at any time t, the position is given by x of t equals that mess. For what values is a particle at rest? Particle at rest. When is my velocity equal to 0? So how do I go from position to velocity? I take the derivative. So the derivative of sine is cosine. Derivative of my inside function is 2 pi. The derivative of 2 pi t is just 2 pi. I want to know, when is that thing at rest? When is that equal to 0? I see a 2 pi common in both, not the inside 2 pi, but this 2 pi and that 2 pi. I'm going to factor that 2 pi out, factor that 2 pi out, and this becomes a 1, and that goes away. So when is 2 pi equal to 0? Never. It's 2 pi. When is this equal 0? When is cosine of 2 pi t plus 1 equal to 0? Well, that would be when cosine of 2 pi t equals a negative 1. So then I have to inverse cosine. Cosine of what function or what value is equal to a negative 1? Unit circle. Cosine is my x values. Negative 1 over here. So that would be at pi. So then 2 pi, t has to equal pi. Solving by t, I divide by 2 pi. I divide by 2 pi, and t equals 1/2. 27 looks like letter D. Okay. 28. Graphs can be hard. They can be easier if we have little tricks, but they can be hard. So let's talk about some tricks. When I do these, first thing I do is I want to find out, where do I have horizontal slope fields? Where's my slope field horizontal? That would be anywhere y is equal to 1. Be careful. It looks like it's 2, but we're counting by halves. How do I know that? Because of their label. They gave me that 3 is way up there. So I want to know when y equals 1, my derivative is 0. When y equals 1, my derivative is 0. Well, that's kind of hard to see right here. What I see is an x common in both. So I'm going to factor it out. Now I can see it. When y is 1, x is 0. So this is a possibility. When y is 1, not 0. When y is 1, not 0. Could be, but every time y is 1, doesn't matter what x is, it's 0. And that's not true for B and C. When y is 1, x is 0. Sorry, the function is 0. That is true here. There's an option. And that is true here. Okay. What else do we notice? Let's go to the left-hand side. Or above. Let's do above. When I go to the left-hand side above, up here, when my y values, sorry, I gotta get rid of that mess. When my y values are greater than 1, and my x values are less than 0, when my y values are greater than 1, and my x values are less than 0, every single one of these slopes is negative. When my y values is greater than 1, this will be positive. When my x values are less than 0, these will be negative, and all of these will be less than 0, they'll be negative. A is still in the running. When y is greater than 1, this is positive. When x is less than 0, this is still positive. That's no longer in the running. Down here, this one says it doesn't matter what x is, just matters what y is. That's not true. When y is greater than 1, this would be positive, and so those are out. Letter A. Okay, so that's the end of this section. Now, the current AP Calc test has actually 30 questions on the no calculator part, but this is a 2014 released before they changed the format, so there's only 28. Questions are still same concepts, everything's still good. You just recognize on the real test, the new test, you're going to have 30 questions on the no calculator part. Okay, if you found that helpful, make sure you check out the other 3 parts where I talk through the calculator part, multiple choice, and then the 2 or free response questions or sections. Thanks for watching. If you found these videos helpful, you can find other videos in my series, and don't forget the reviews where I talk through a bunch of practice problems. Have a great day.